Hey everybody, Mr. Stewart here, and welcome to the second screencast that's going to hopefully serve as support for your learning about how you can verify geometric properties. So those are the properties of a variety of shapes, triangles, quadrilaterals, and or circles. So here's the learning goal as it was in the first video, same as this one. But this time through, I think we'll deal with circles. So although you may not be using circles in your inquiry, and that's fine. There are many properties for which you're accountable for, and geometry does come up as you spend more time in mathematics from year to year, and certainly after high school, depending on your degree program. So let's take a look at another example. So here we go with this one. So you're being asked if the right bisector, otherwise called a perpendicular bisector, of the chord AB, does it pass through the center of the circle? Okay, so there's an equation of a circle with a particular radius, and we have some coordinates. So just a little background on the notion of the word chord. So if that has not come up before in your experience, so just draw a bit of a circle here. So a chord, more or less, if you draw any 2 points on the circumference of a circle and you join those 2 points, then what you have is a chord. Okay, so this is a chord. Now let's assume that the center of this circle happens to be here. Okay, so the chord, or the longest chord for a circle, is none other than the diameter. Okay, so the diameter too, it is a chord, and it is the longest one for a circle. So a little background for you on circles and chords. So I'm just going to cut that out for now. And remember, anything that comes up, pause it, summarize, write down questions if you happen to ask me or that you want to research further online. And also pause so you can complete some notes. So let's start in here, and it appears as though point A, which you can see here, we're being told that this is on the circumference of the circle as well as point B. So let's go ahead and plot those. So 10, 5 is here. That's point A right there. So 10, 5 is A. And then 2 minus 11, which is off my grid, but right around here, that's point B at 2 minus 11. Okay, so with those 2 points, I guess we can get a sense or an idea that the circle has to be large enough to pass through those. So I'm just going to draw something here, and we'll see if we can't affect the size of that circle. Now it has to be centered at the origin. So because we're working with circles in standard position, so we're just going to try to increase the size of that circle such that it's centered at the origin, but also going through those 2 points. And you can see that slowly but surely I'm getting there. Now, what might be more helpful in terms of sizing that circle out with my technology is if I actually knew the radius. So let's grab a hold of that equation that we have over here, okay, which is x squared plus y squared is 125. And recall that the general equation for a circle is the sum of those squares equaling the square of the radius. So it follows that the radius is the root, or the positive square root. And remember how there are 2 square roots. You could have a positive and a negative square root, so we're restricting the value of r to be greater than 0. I guess it could be equal to 0, but you wouldn't have much of a circle. You'd simply have a point at the origin. So let's go ahead and find the root of 125. Because that's exactly what r squared is equal to. So the sum of x squared plus y squared is 125. That will give you the value of r. So Let's just calculate that quickly. You can do that too if you so choose. So having trouble finding the calculator, I'm just going to reduce the screen here for a moment, see if it's in. Here we go. I have a couple copies of it. So I just need the root of 125. Should be 11 and change. It's about 11.2. So 11.2 is the radius of the circle. So I'm expecting to increase the circle just to go a bit beyond that value there. It should land here or just beyond that. So at 11.2, just a little further along. So I'll take a moment to increase the circle size. And it does have to be centered at the origin. And you can see we're almost there in all directions. Just a little bit more. And that looks to be about close enough for a rough sketch. Okay, so it doesn't have to be perfect as we are sketching it. And if you plotted it with technology, you definitely get more precision. So now let's get on with the task at hand. Does the right bisector of chord AB go through the origin? That is the center of the circle in standard position. So let's see. The chord would be here. Oh, sorry, here. Between those two, I'm going to color code that line differently so it shows up nicely. And we'll just change the color of that. Let's make it a bright red. And we'll go back to full screen. So we have our chord in place, and then we also would like to know, so does its right bisector go through the origin? So we do need to see a right bisector to that. So I'm going to sketch something in relative to that, and we can always change its location after. So I'm going to assume that that's perpendicular to AB as far as my sketch is concerned, and later on we can alter that if needs be. Okay, just going to extend that bisector through as it is a line. So we need to work away at that. Visually you can see it is a bit off, but you know what? What I'm going to do is perform some calculations, and that will help me to determine the position of the right bisector. Okay. So remember that the bisector, okay, so let's just type this in here. So the bisector of AB will pass through the midpoint of AB, of BC. So the right bisector of AB will pass through its midpoint. So that's midpoint AB. Just going to drop the font size on that. Just so we have more space on the screen. So what we really do need to do now is to find out the midpoint of AB, and then we'll know where that bisector happens to go. So let's go ahead and do that. So the midpoint of the bisector, sorry, of the chord AB. So midpoint of chord AB. Mixing my words here. So let's average the x values. We'll average the y values. So it's plus negative 11, or 5 minus 11. So we'll do the math on that. And 12 halves is 6. And then we have negative 6 halves is minus 3. So now we can go back to our sketch, and we can label the midpoint of chord AB as being here. Okay, so that's our midpoint. That's 6 minus 3. And with that, I can adjust the position of my bisector. So visually, it looks like it is much more appropriate, okay, in terms of how it's moving through that. So what we're doing is we are drawing, this is the bisector, and we are supposing that it is cutting through at an angle of 90 degrees. Okay, so let's move on with our solution. We now have the bisector in place, we have a midpoint. So what we need to do is, if it really is the right bisector going through the origin, then we're going to have to deal with some slopes. Okay, so let's go ahead and determine the slope of chord AB, followed by the negative, followed by its negative reciprocal, which would be the slope of the right bisector. Okay, so let's get a jump on that and see what we can do with that. Okay, so extending the page here a little bit. So the slope, so small m, not uppercase M for midpoint, but the slope of AB, so a rise over run, or a change in y over the change in x. So y2 in this case, if we go with point B as being x2, y2, so we'll take minus 11, and from that we're going to subtract a y value of 5. And then in terms of our denominator, we'll have 2 minus 10, which gives us minus 16 over minus 12, oh, my apologies, minus 8, which gives us a slope value of chord AB as positive 2. Okay, so recall that I mentioned the word negative reciprocal, which would end up being the slope of the right bisector. So let's go ahead and do that. So the slope of the right bisector, or perpendicular bisector, why don't we denote that as line 1, L1. So that implies that slope of line 1, or the perpendicular bisector, would be equal to the negative reciprocal. So that is what happens when you take the reciprocal of slope AB. So it's the negative of 1 over the slope AB, which is equal to minus 1 over 2. Okay, so there we have the slope of the perpendicular bisector. So far so good. We're really close to a final answer. So let's think about the last thing that we're going to need. Okay, so if we have the slope of this line, the only thing that remains is whether or not it passes through that origin. Okay, in fact, does it have a y-intercept of 0? So let's go ahead and determine the y-intercept for the perpendicular bisector line 1. Okay. And by doing so, what we'll see is that we're going to be able to determine if it passes through that origin. So far, if we consider the equation for line 1, we'd have y equals the slope multiplied by x plus the unknown y-intercept. So all of this time, we've had this midpoint just sort of hanging out here, not of much use, but it is another point on the line we can use. So why don't we go ahead and figure out the slope of that, or sorry, the y-intercept, by substituting in the coordinates. So why don't we set the x value to be 6 and y as minus 3, and recall those are the coordinates of the midpoint of chord AB. So in goes minus 3, we'll take the negative half of 6 and we'll solve for b. So let's see here. Half is 6, 3, so minus 3. Well, this is going to work out great because when we balance that, we'll need to add 3 on each side. And what we can see is that 0, in fact, happens to be the value of the y-intercept. Okay? So therefore, we can see that the equation for the right bisector, or for line 1, is y equals minus 1/2 of x plus 0, as there is no y-intercept other than, 0. So therefore, we can answer the question by saying, yes, it does pass through. So which does pass through the origin? Okay. Just want to get the words right on this, make sure I'm answering the question properly. We did start out with, yes, it does. So it does pass through the center of the circle. I'll be a bit wordy here at the end, it's a little more formal. Okay, so the equation for line 1, or the right bisector, is y equals minus 1/2 x, which does pass through, okay, based on our proof, through the center of the circle with that equation, and center 0, 0. Okay, so a circle in standard position. And that concludes the video.